Hey guys, in this video the brilliant Mr. B is going to be taking you through quadratic graphs. Now this is quite a long video because it is quite a complex topic but comes up on pretty much every single exam paper, so it is something you need to know really well. Now there are 15 different examples here at 3 different levels and you can jump into this wherever you want to. You don't have to start at the beginning and then work your way through to the end. You can start in the middle, and if you find that too hard you can go backwards, or if you find it too easy you can move forwards. This video is here for you to use at your own pace. And if you want loads more practice questions, then they're all waiting for you over on my website.
We are going to have a look at quadratic graphs. Now, when you're plotting any sort of graph, every single point on a graph has a x coordinate and it has a y coordinate. So when you're plotting a graph, it's always in reference to an x and a y coordinate. Now, for question 1, we are told what the y coordinate is. Y is equal to x squared. So y and x squared are the same thing. But what is x equal to? Well, we don't know what x is equal to. So what we need to do is we are going to assign x some values and see what happens. Because we give x some values, because y is defined in terms of x. For this question, y is x squared. We'll get values for x and for y. Now, which values do we choose for x? Well, you can choose depending on the context of the graph, but it's usually easiest to look at 2, 1, 0, -1, and -2. And you can look at 3 and -3 as well. That's really common, and lots of examples will ask you specifically to go to 3 and -3 as well. But depending on the scale of the graph and what the axes are like, you could be finding all kinds of numbers here. So you get to choose what x is. So we have our x coordinates, but what about the y coordinates? Well, y is x squared. So if x is 2, y would be 2 squared, and 2 squared is 4. If x is 1, y would be 1 squared, and 1 squared is 1. If x is 0, y would be 0 squared, and 0 multiplied by 0 is 0. If x is -1, y would be -1 squared. And -1 multiplied by -1, well, 1 times 1 is 1. But a negative multiplied by a negative is a positive. So we get +1. And if x is -2, y would be -2 squared. So 2 times 2 is 4. And a negative multiplied by a negative cancels out, gives you a positive. So now we have a set of coordinates. We have 2, 4. And we can plot that on the graph. So the first graph, I'm going to go 2 across from the centre and 4 up and plot that point. We have 1, 1. So again, I'll be plotting that from the centre, 1 across and 1 up. And then we have 0, 0. So plotting that directly in the centre, 0 across and 0 up. Then going to the negative numbers, we have -1 and +1. So on the x-axis, a negative means I'm going left and then up 1 for the y coordinate. And for the final one, we have -2 and 4. So again, going left on the x-axis for -2, going 2 to the left, and then 4 up on the y-axis. And I've started to plot the graph. Now, what you can do once you've plotted some coordinates is that you can start to sketch. So I'll have to freehand this. You can start to sketch the curve. Try and make sure it's a curve. It's not a dot to dot, and we're not doing straight lines in between every coordinate. But what I have now, my curve in blue, it looks a little bit incomplete. And that's because there's nothing above that point. There's nothing for, say, 3 and -3. So the next point we would do here is we would find x equals 3 and x equals -3. Now, I'm not going to do this for every question, but I'll do it for this one just to show you. Because I don't want to bore you doing too many examples. So if x is 3, y would be 3 squared. So you can see I'm just adding an extra one. It's out of order. You know, it's after -2, that doesn't matter. 3 squared is 9. And so my new set of coordinates, I've got 3 and 9. So let's plot that. So positive on the x-axis will be to the right and then up 9. And now you can see I'm actually getting quite far up towards the top here. So I can continue my curve and maybe just continue all the way to the top and just do a little estimation of where it would continue. Now you might have noticed this is symmetrical. Look at the numbers. We have 4, 1 and 0. And then 0, 1 and 4 for the y coordinates. So because everything's symmetrical, I'm going to guess that -3 would also give us +9. If I plot that one, I can now complete my graph. So you will see patterns within these graphs. You do see a pattern. Do feel free to take that pattern forward and not need to work out every single point. What I would say is before finding a pattern, make sure you've got at least 3 points that prove that pattern's working. Don't just guess a pattern after 1 or 2 examples. You need at least 3 usually for a pattern. And now I finished the first question. And now I'll just show you a version of that that's been plotted with my computer. And as you can see, the computer plotted version is very, very similar to the one that I did freehand. So I think I did a pretty good job there. Moving on now to question 2. Remember, with any graph, we're always going to be doing this in reference to x coordinates and y coordinates. So let's write those down. And then we know what y is for question 2. It says that y is equal to x squared plus 2x. There's nothing about what x is equal to, so x is going to be a variable where we can choose the values. And again, I'll be starting off with 2, 1, and 0, -1, and -2. And later on, if that's not enough, like the previous question, we can always add more on if we need. For example, 3 and -3. So let's start to work it out. If x is 2, then y would read 2 squared plus 2 times 2. So all I'm doing here is use my substitution skills. I've swapped x with a number I've assigned x. And remembering algebra facts like if you have a number and letter next to each other, they are being multiplied. Then need to work this out using BIDMAS rules. So indices will come first. 2 to the power of 2 is 4. They'll be adding on the 2 times 2, which is also 4. So that's going to give us 4 plus 4, which is equal to 8. So we have our first set of coordinates which we can plot. We have x equals 2 and y equals 8. So I'm going to go to the center of the graph. I'm going to go 2 to the right on the x-axis and 8 up on the y-axis. I'm going to draw the coordinate. So let's work out the rest. If x is 1, then y would be x squared plus 2 times x. 1 squared is 1. 2 times 1 is 2. 1 plus 2 is 3. Now, I'll not draw that just yet. Let's work out the rest. So then we'd have, if x is 0, we'd have x squared plus 2 times x. 0 squared is 0. 2 times 0 is 0. 0 plus 0 is 0. Nice and easy. And you'll often find this where if you're saying that x is equal to 0, it's going to cancel out a lot of the calculation by multiplying by 0. Often giving you 0 as an answer, but not always, as we'll see later. Now, when x is -1, we'll have -1 squared plus 2 multiplied by -1. So then using BIDMAS to the indices first, -1 times -1 is a +1. Then using BIDMAS to do the multiplication next, 2 multiplied by -1 is going to give us -2. So 1 plus a -2. Remember, a plus and a minus together, that's going to cancel out and give a minus. So 1 take away 2 is -1. And the last one I'm going to do here, -2 squared plus 2 times -2. So again, just swap in the number -2 in for x. -2 squared is a +4. Remember, negative multiplied by negative gives you a positive. And 2 times -2 will give us -4. So 4 plus a -4, that's going to give us 0. So let's plot these. When x is equal to 1, y is equal to 3. 1 to the right, 3 up. When x is equal to 0, y is equal to 0. So plot that right in the middle. When x is equal to -1, y is also equal to -1. So 1 to the left and 1 down on the y-axis. Negative y-axis values are going downwards. And then we've got -2 on the x-axis and 0 on the y-axis. So we go 2 to the left and 0 up. Now, again, we can start to join this up, but it's not complete yet. We're missing some values. Now, Quadratic graphs are always symmetrical, and we can see the curve's gone down and it's starting to go back up. And we can see with our numbers, we've got 8, 3, 0, -1. But then we get 0 again. So I'm going to guess it's going to go back up. And I would guess that the next answer is going to be 3 again to make this symmetrical. So let's double check that. So I'd want -3 next. So -3 squared plus 2 times -3. -3 squared is 9. And we're adding on 2 times -3, which is -6. And 9 plus a -6 does give us 3, so I was right. So now I spotted how this is symmetrical. So with -3, we get +3, and I can plot that. 3 to the left, 3 up. But now I also know that -4 is going to be 8 up to make this symmetrical. And so I've worked out a couple of coordinates there without actually doing the maths because I've spotted the pattern. We can also see the distance between the points getting larger and larger and larger. So there's no point looking at -5 because I know it's just going to kind of come up a little bit further following the same curve. So let's have a look at the computer version and see how close I got. And there it is. And I think with the computer, the only thing is that the bottom of the curve is a little bit clearer. So make sure you do use a nice thin pencil. And now you can see I filled the page up with working out. So I'll rub this out now and we'll start the next 2 questions. So for question 3, again, it's a graph. It'll be in terms of X and Y coordinates. We don't know what the X coordinate is going to be, but we're told what the Y coordinate is. Y is equal to X squared minus 2X. So we can choose the values for X. So again, we'll go with 2, 1, and 0, -1, and -2 to start. So let's work out our coordinates by swapping the X with the numbers we've chosen. So when X is 2, we're going to have X squared minus 2 times X. When X is 1, X squared minus 2 times X. X squared minus 2 times X. X squared minus 2 times X, and X squared minus 2 times X. You'll notice every single time I said X, I wrote down the number that I had on that row instead, giving X that value. So let's work these out. 2 squared is 4. Take away 2 times 2, which is also 4. That gives us 0. 1 squared is 1. Take away 2 times 1, which is 2. 1 take away 2 is -1. Multiplying by 0 is going to give us 0. No point even looking at that. -1 squared is +1. And we are going to take away 2 times -1, which will give us -2. And 1 take away -2. Double negative cancels out to give us a positive. 1 plus 2 is 3. And then -2 squared is 4. And we're taking away 2 times -2, which is -4. So again, they're going to cancel out. 4 plus 4 is 8. So let's start to plot these coordinates and see what we've got. So we have 2 and 0. So we'll plot 2 to the right and 0 up. We have 1 and -1. So 1 to the right and 1 down. We have 0 and 0. So we'll plot that right in the center. We have -1 and 3. So I'll go 1 to the left and 3 up. And we have -2 and 8. So 2 to the left and 8 up. And now we can see the beginnings of our curve. Now it's going to be symmetrical, so I'm going to guess that the other coordinates are going to go in the positions where I'm drawing the blue dots. And you can see they're the same distance away from the other dots, except it's just kind of flipped around. The big clue here is that on the y-axis, the groups of dots are at the same height. And on the x-axis, I'm going to the right by 1 each time. And when you get familiar with the patterns with these kind of graphs, especially quadratic graphs, you will start to do things like this and skip ahead and not work out. For example, in this case, x is 3 and x is 4, because it's obvious what they're going to be based on the graph and based on your knowledge and what quadratic graphs are like. So let's join it all up. So I'm doing this freehand. There isn't really a way to do this. It's not freehand. So make sure you've got your pencil ready and your rubber, and you can change things if you need to. And now let's see what the computer drawn version looks like. And again, I'm quite happy with that. It looks fairly close. I just want to point out the difference between the second and third answers here and the equations of the lines. So in question 2, it's plus 2x, and in question 3, it's minus 2x. So they're very similar, it's just a sign that's switched. And if we look at the two graphs, they do look very, very similar. And it looks like, to me, where it's plus 2x, the whole thing has moved 2 spaces to the left compared to the first answer, y equals x squared. Whereas with a minus 2x, the whole thing's moved 2 places to the right. Now, you might be expecting a plus 2x to move you to the right, but instead it's gone to the left, to the negative side. So it's kind of like the opposite way around you'd expect. And that often happens with graphs and working with the x-axis. And the next question also has quite a similar equation, where it's x squared plus 2x, but then it's minus 8. So we'll have a look now what the effect that minus 8 has. So the plus and minus x terms move us left and right. Could it be that that minus 8 might move us down 8 places or up 8 places? Let's have a look. So it's going to be x squared plus 2x take away 8. So again, we'll choose the same values of x. Been working quite well so far. So we're going to have 2, 1, and 0, -1, and -2. So let's substitute first. So we're going to have x squared plus 2 times x take away 8. X squared plus 2 times x take away 8. The 0 squared plus 2 times 0 take away 8. And you'll notice this time I haven't just gone all to 0 because it's not all multiplication based, with the 0 squared being 0 times 0 and the 2 times 0. We've got to take away 8, so I think we're probably not going to get a 0 for the answer in that one. Then for the negative numbers, x squared plus 2 times x take away 8, and x squared plus 2 times x take away 8. We have to follow BIDMAS order, so squaring first. So 2 squared is 4. Then we have to do the multiplication. So it's the 2 numbers on either side of the multiplication sign. So 2 times 2 is 4. And then at the end, we can do the pluses and the minuses. So 4 plus 4 is 8. Take away 8 is 0. Next question, indices first. 1 squared is 1. Then multiplication. 2 times 1 is 2. And take away 8. 1 plus 2 is 3. 3 take away 8 is -5. Then we have 0 squared plus 2 times 0 take away 8. So 0 plus 0 is 0. Then we take away 8, we get -8. Moving on to the negative numbers. So again, indices first. -1 squared. And we're squaring the whole thing, including the negative part of the -1, which will be important for the next question. -1 squared is -1 multiplied by -1. That's going to give us +1. Then we have to look at the numbers at either side of the multiplication symbol, and it's the 2 and the -1. 2 times -1 is going to give us -2. And then we take away 8. So 1 plus a -2, 1 take away 2 is -1, and -1 take away 8 is -9. And then for the last one, indices first, -2 squared is 4. And again, look at the numbers at either side of the multiplication symbol so you don't get confused. It's a 2 and a -2. So we're adding on 2 times -2 is -4. And then we're taking away 8. So 4 plus a -4 is going to give us 0. And 0 take away 8 is -8. So let's try and plot these. When x is 2, y is 0. 2 to the right, 0 up. When x is 1, y is equal to -5. 1 to the right, 5 down. When x is 0, y is -8. So staying in the middle on the x-axis, but going down 8 places. When x is -1, y is -9. So 1 to the left and 9 down. And finally, when x is -2, y is -8. So 2 to the left and 8 down. And you can see now the curve is starting to go back up. So we can kind of see where this is going to be symmetrical. So at either side of the -9, we've got the two -8s. So I'm going to guess that -3 would give us -5, and -4 would give us 0. Now, with this, I can't really draw a full curve with this because I've only got the curve in the bottom portion of my set of axes. There's nothing at the top. So it's going to be important now to work out 3. So that would be x squared plus 2 times x, take away 8. 3 squared is 9. 2 times 3 is 6. And we are taking away 8. So 9 plus 6 is 15. And 15 take away 8 will give us 7. So then the coordinates I have here are x is 3 and y is 7. So that's 3 to the right and 7 up. And again, with this being symmetrical, if I go over to the left and I find the previous coordinate I've drawn to the left and go one more to the left, it's going to be on the same level. It's going to be on 7 to make this symmetrical. So as you can see, we start off with the easy substitutions between 2 and -2. But if that's not good enough, if that's not helping you draw the graph, you can always add more on. And in the exam, you just continue adding numbers until you're confident you can draw it. So now let's try and sketch the curve. Again, unfortunately, this has to be freehand. Do not join dot to dot and make sure there's a curve in between each coordinate. If you join them up with a ruler, you are going to lose a mark. So that's my attempt freehand. Now let's look at the perfect computer-drawn answer. And now let's move on to the final easy question. And the last question is really important. It looks very similar to the first question. The first question was y equals x squared. This question is y is equal to -x squared. So looking at this, y equals x squared, our first answer, we get a symmetrical curve. Then we looked at the effect of adding on extra x's. And with the plus 2x and minus 2x, we saw that shifted the graph to the left or to the right. We can also see that it shifted those graphs a little bit downwards as well. So it wasn't as simple as left and right. And then when we add the takeaway 8 at the end, with question 4, it now looks like the curve is much bigger, but that's an illusion. And all it is the curve's being moved down 8 places. And if you move the curve down 8 places, you reveal the larger part of the curve that's lurking above the graph. Because if you think about it, this set of axes is a little snapshot into the curve that only goes 10 units in either direction. You could draw the graph much, much larger and you see much more of the line. And that's what happens when you move it downwards like this. So what effect does a negative at the start have? So again, I'm going to start off the same way. We'll assign x some values like 2, 1, 0, -1, -2. And let's look at -3 as well. And again, we are going to substitute. So if y is -x squared, that would be -2 squared, -1 squared, -0 squared, then -1 squared, -2 squared, and -3 squared. Now, what's important here is that we do the indices first, but when we're squaring, we have to decide, are we squaring the 2 or the -2? Which one is it that we're squaring? And in some of the previous questions, we were including the negative number in the calculation. Now, part of this is that the question is worded ambiguously. So, for example, you can have -2 squared. We could put brackets around the entire -2. And then that would mean -2 multiplied by -2, which is 4. You can also have the brackets only around the 2. But what that means is the 2 is being squared. That would be 2 times 2, but the answer is going to end up being negative. So 2 times 2 is 4, but that negative on the outside of the brackets has to be included, and we get -4. So which one are we looking at here? Well, we're just squaring the thing we substituted. So with -2 squared, we are doing 2 squared, which is 4, so it'll be -4. So the negative is just being added on at the end. So 1 squared is 1, pop on the negative. 0 squared is 0. Now you can pop on the negative, but there's no such thing as -0. It's going to stay as 0. Then we have -1 squared, which is 1, and pop on the negative. So this is where it gets a little bit confusing. And if I show you again with the brackets, what we're effectively doing is both with this question. So we have the -2 practically inside the brackets, which means -2 multiplied by -2. And then whatever the answer to that is, we're making it negative. So -2 times -2 is 4, and we pop on the negative sign. So that was -4, and then the same thing with -3. -3 squared is 9, and then pop on the extra negative symbol. So again, it gets a little bit confusing with the negative numbers, but now we can plot this and see the effect that negative symbol had. So when x is 2, y is -4. So 2 to the left and 4 down. When x is 1, y is -1. So 1 to the right and 1 down. When x is 0, y is 0. When x is -1, y is -1. So 1 to the left and 1 down. And now we start to see now the beginnings of the symmetry, because now we have -4 going along with our -2. Now we plot this, 2 to the left and 4 down, you can maybe start to see what's happening here. So we definitely have some symmetry. Let's look at the next one. -3 and -9. So let's plot those. 3 to the left and 9 down. So what I'm hoping seeing here is that we still have a curve, but the curve is now upside down. And that's the effect of the negative at the start. It just flips the whole thing upside down. It's been reflected in the x-axis. Using symmetry, I'm going to guess that a +3x would give us a -9y. So I guess the one I've just drawn in blue, and then let's join it up. What we should be seeing is exactly the same as the answer to question 1. It's just upside down. And now you can see the accurately drawn answer. Moving on to the medium questions, we now have exactly the same thing, but just a more complicated combination of x and number terms. So, use the same method. The graph is going to be using coordinates. We're going to have a x-coordinate and a y-coordinate. We aren't told anything at all about the x-coordinates, so we get to choose, but we are told about the y-coordinate. And for the first question, y is equal to x squared plus 5x plus 6. So we need to substitute in values of x, which we can choose. And again, the best ones to go with are 2, 1, and 0, -1, and -2. See if those work, and if they don't, we can choose more values later. So x squared plus 5 times x plus 6. So again, substitute in the x's for the number we've given x. Use big mass order, so indices first, 2 squared is 4. Then multiplication, 5 times 2 is 10. And then the additions. 4 plus 10 is 14, plus 6 is 20. Now, with that, we're going to have x is 2 and y is 20. That's not actually going to fit on the graph because these only go as far as 10. So this will happen sometimes. You'll do substitution and you won't be able to plot the coordinate. All that means is that we need to continue and try and find numbers which will give us smaller coordinates we can plot. Again, the next one will be a 1. I get a feeling that 1 will be a little bit smaller, so let's check that out. So to substitute, we'll have x squared plus 5 times x plus 6. 1 squared is 1. 5 times 1 is 5. And add on 6. So 1 plus 5 is 6. And 6 plus 6 is 12. Now again, with this set of coordinates, it is still too large to plot. These graphs go up to 10. That's a 12. But we are getting closer. So now let's have a look at the 0. So we'll have 0 squared plus 5 times 0 plus 6. Again, noticing all I've done each time is change the number that takes the place of the x. 0 squared is 0. 5 times 0 is 0. And we have the 6. 0 plus 6 is 6. And now we have the first coordinate that we can plot. 0, 6. So 0 on the x-axis, stay in the centre, and then 6 up. Now let's look at -1. So x squared plus 5 times x plus 6. -1 squared is a +1. Again, we substituted the entire -1, so we are doing -1 multiplied by -1. It's not a case that negatives on the outside and just pop it on at the end. Then the multiplication, look at the numbers at both sides of the multiply sign. 5, a +5, and a negative 1. So we're adding on 5 times negative 1 is negative 5. And then adding on the 6. So 1 plus a negative 5 will be negative 4, and negative 4 plus 6 is 2. Looking at the coordinates, we have negative 1 to get to plot quite easily. So 1 to the left and 2 up. And then for negative 2, that would be x squared plus 5 times x plus 6. So indices first, negative 2 squared is positive 4. Then multiplication, 5 times negative 2 is going to give us negative 10, and then add on the 6. So 4 plus negative 10 will give us negative 6, and then add on 6 will give us 0. So then we can plot that, negative 2 and 0. That's 2 to the left and 0 up or down. Now, from this, we can't actually plot our curve because we only seem to have one half of the curve. And because those values at the start were quite large, it didn't really help us. So we're going to have to continue now. So let's look at negative 3. So negative 3 squared plus 5 times negative 3 plus 6. Negative 3 squared is 9. We're going to add on 5 times negative 3, which is negative 15, and add on the 6. So 9 adding on negative 15 is going to give us negative 6. And then add on 6, that will give us 0. And plotting the coordinates, we have negative 3 and we have 0. So we can plot 3 to the left and then 0 up. And we can see now we're finally starting to repeat numbers. And now I can work out the rest of the curve. So I've got a 0 and a 0. So then on the other side, I must have a 2 and then a 6. So my curve's going to look something a little bit like this. And then when you draw it, when you come down to 2 zeros, it's not going to be flat. It will dip a little bit below the zeros. So just show that a little tiny bit. And then come up. Now, plotting this, it's kind of difficult. It's a little bit far away from the top for me just to draw a little bit of an extra line. So I'm going to have a look at that 112 coordinate. So when it's 1 up, 1 across and 12 up, it was going to be something like, rough estimation, somewhere where I'm drawing the dot there, and the same on the other side. So that's just a little bit of a guide to help me understand roughly where the curve's going to go. But that dot is not actually part of what I'm drawing, just to help me kind of get it in the right direction. So now let's have a look at the accurate version drawn with the computer. And you can see I wasn't too far off, and you can see in between the 2 0 coordinates, the curve just dipped down a little tiny bit below. So again, I'll move on to question 2 now, and I'll rub out all the working out because it's taken up quite a lot of space. But don't worry about that because these questions will be worth quite a few marks. As usual, it'll be referenced in terms of x and y coordinates. We aren't told anything about the x coordinates, but for the y coordinate, we are told that it's x squared, take away 8x plus 12. So let's use our usual set of substitutions and work out some coordinates. Now I'm going to start speeding up at this point. So I'm going to have x squared be 2 squared. Then I'm just going to quickly fill in the rest of them so you don't have to sit through me substituting every single time. You should know by now how substitution works. So we're taking away 8 times 2, and then the rest of the 8's multiplied by x. So again, just speeding through this. Then at the end, we're adding on 12. So now I've done my full set of substitutions. We can start to work it out using BIDMAS, doing indices first. So 2 squared is 4. Take away 8 times 2 is 16 plus 12. 4 take away 16 is negative 12 plus 12 is 0. Then we have 1 squared take away 8 times 1 plus 12. 1 take away 8 is negative 7. Negative 7 plus 12 is 5. Then we have 0 squared, take away 0, plus 12. That'll give us 12. Negative 1 squared, take away 8 times negative 1, which is negative 8 plus 12. So 1 take away a negative 8 is 9, and 9 plus 12 is going to give us 21. Now, at this point, the numbers are getting bigger and bigger and bigger. So there really isn't a point of looking at -2. It's not going to help us. It's going to give us a number so big we can't plot it. And look at the numbers I've got. Look at the y-coordinates. I've got 0, 5, 12, and 21. That's not going to give me a full curve. So I want to go towards smaller values, and since deeper negative numbers won't help, let's look at positive numbers. So what about using 3 and 4? So we're going to have a substitution, as usual. Swap that for the new numbers, and we can work that out. So 3 squared, take away 8 times 3, plus 12, and 4 squared, take away 8 times 4, plus 12. Let's see what we get. So 9 take away 24 will give us -15, and add on 12, that'll give us -3. Then 16 take away 32 will give us -16, and add on 12 will give us -4. And again, looking at this, I have no repeat values, and with a symmetrical curve, I want to get those repeat values when the curve goes back around to the side. So what I'm going to do as well is I'm going to rub out -1, because that was giving me 21. That's way too big. I don't need that bit of working out. It's not helpful. I can't plot it. So then looking at 5 squared, take away 8 times 5, plus 12. We have 5 squared, take away 8 times 5, plus 12. So 25 take away 40 is -15. And we add on 12, we get -3. And we can see we had -3 also for x equals 3. So now I've got a repeat value, I can now start to construct the curve. And we only need one repeat value to get an idea of what the other side is going to look like. So let's start to plot. So we have 2 and 0. 2 to the left, 0 up. We have 1 and 5. 1 to the left, 5 up. 0 and 12. We're not going to be able to plot this, but it might be helpful to do a little estimation to help us plot the upper part of the curve. So it's going to be right bang in the middle, and 12 up will be roughly, just a little estimation, somewhere up there. Then we're going to have, so done 2, 0, we've done 1, let's do 3. So I'm doing these out of order, but I'm just trying to get the numbers in order. So 3 and -3, so 3 across and 3 down. After 3, let's have a look at 4. 4 and -4, so 4 across and 4 down. And then let's look at 5, we've got 5 and -3. So 5 to the right and 3 down. And now we've got that repeat value, we can now make the rest of it symmetrical. So I'm going 1 to the right each time, but drawing the dot at the same level as a previous one, going all the way up. And there's my curve. So now I can start to plot the curve freehand, making sure it's not joining up the dots. It is a curve in between every single coordinate. I just estimate at the top how far up it's going to go. So it'll be something like that. And now let's have a look at the accurate computer version. And there it is. Moving on to question 3. Again, we know nothing about x, but we're being told that y is equal to x squared plus 14x plus 45. Now, I'm choosing my values here. I've got to keep in mind that I can't plot anything that's above 10 because of the size of the kind of graph I've got. And when I'm choosing the value I'm going to substitute into, I'm seeing that plus 45. Now, if I put a positive number into this and I add on 45, I'm going to be way beyond 10. So what I'm going to do here is I'm only going to be looking at 0 and below. So look at 0, -1, -2, -3, and -4 to start. So we start off with 0 squared plus 14 times 0 plus 45. And again, I'm just going to speed through this now and just swap all those zeros with all the other numbers. We're going to substitute in. So we have our x values squared, adding on 14 multiplied that x value, and then we're adding on 45. And then we can start to work these out. Indices first, 0 squared plus 14 times 0 plus 45 is 45. So as predicted, way too large to plot. So it's a good idea not even looking at 1 and 2. Then we have -1 squared plus 14 times -1 plus 45. So 1 plus -14 gives us -13. Then add on 45, we've got 32. Again, still way too large to plot. Look at negative 2 squared, plus 14 multiplied by negative 2 is negative 28. This middle number here, this is going to be crucial. I need to get this to be quite large to cancel out the 45, which has always been added on the end. So 4 plus negative 28 gives us negative 24, and add on 45, we've got 21. Again, still too big. Negative 3 next, negative 3 squared, plus 14 times negative 3 gives us negative 42, and then add on 45. So 9 plus negative 42 gives us negative 33, and add on 45, and I'm getting 12. So while I still can't plot that with a 10 by 10 graph, I'm now getting close to where I can start to get some values that I need. Negative 4 next, negative 4 squared, plus 14 times negative 4, which is negative 56, and add on the 45. So 16 plus negative 56 is negative 40, and add on the 45, got positive 5. So now I do have something that I can plot. But I can't just plot one coordinate, so I'm going to look at the values that I found, and I'm just going to rub out the ones that I don't need. So I didn't need to substitute anything from 0 down to negative 3. They won't give me anything that was useful. Perhaps the negative 3 and the 12 might be useful just to fill out the end bit of the curve. So all I'll do for that is just do a quick little note that negative 3 gave me 12. So I tried to anticipate which numbers I'd need, and I had a go, and I still got a lot of numbers that I couldn't use. But that's okay. For the third time, I'm going to change my plan. So I've got negative 4, that worked out. Let's look at negative 5, negative 6, negative 7, and negative 8. And these should give me some plottable numbers. So again, let's do the substitution. And again, I'll just write these in quickly because you should know how to substitute. And again, every single equation being exactly the same with a value for x being changed. So now we can start to work these out. So I'll start from the bottom. So negative 5 squared plus 14 multiplied by negative 5 plus 45. And for speed here, I'm just starting to use my calculator now to get some fast answers. But you should be able to do these with a calculator if necessary. So 25 plus negative 70 gives negative 45, and add on 45 to get 0. Then we've got negative 6 squared plus 14 times negative 6 plus 45. So 36 plus negative 84 gives us negative 48, and add on 45 gives us negative 3. We have negative 7, negative 7 squared plus 14 multiplied by negative 7 plus 45. So 49 plus negative 98 gives negative 49, and add on 45 gives negative 4. Now I can see these numbers are getting quite close together now. Went from 12 to 5 to 0 to negative 3 to negative 4. It's a difference of 1 now. So I expect the next answer will either be negative 4 or negative 3, and the curve will start to turn. So negative 8 squared plus 14 times negative 8 plus 45. So 64 plus negative 112 is negative 48, and add on 45 is negative 3. So now on my third attempt at substituting values, I can now see where the curve is for plotting this. So let's start to plot. We have negative 8 and negative 3. So it's going to be 5 to the left and 3 down. Then we have negative 7 and negative 4. Then negative 6 and negative 3. Then negative 5 and 0. Negative 4 and 5. And then just to help us draw the curve, we have the coordinates we found before, negative 3 and 12. Just estimate roughly where that's going to go. And now I've done that, I know that negative 9 is going to be even here, and negative 10 is going to be here. And I can start to draw the curve. Again, not with a straight line or a ruler. In between every single coordinate has to be a curve. And when I hit negative 10 on the x-axis, I actually run out of space. Now you might be thinking, well, shall we continue up here? And we're not. We're only going to draw the graph on the actual coordinate grid we've been given. So that's all we are going to draw. We're not going to draw anything else. It wouldn't be accurate because there's no grids, there's no squares drawn. And with the accurate version, you can actually see that it's actually happening and the curve does actually stop when it hits the side. Moving on to question 4. So again, we don't know anything about the x coordinates, but we do know the y coordinate is x squared take away 11x plus 24. Now, with the previous question, the 14x to 45, they're all positive. So I knew that if I substitute in a positive number, I was going to get bigger and bigger numbers. With this one, it's a negative 11, even though I'm adding 24 at the end, which will go off the graph, the negative 11 will make up for it somewhat. So I'm still going to be looking at some positive numbers here. So we'll look at our usual numbers, 2, 1, 0, negative 1, and negative 2. And if it doesn't work out for us, we can always change it later. So with x squared, substituting our numbers. Again, doing it all at once to save a little bit of time. We're going to take away 11x, which is 11 multiplied by x. And then we're always going to be adding 24 at the end. So substituting in the 2 squared, take away 11 times 2 plus 24. So 4 take away 22 gives us negative 18, and adding on 24 gives us 6. Then we have 1 squared take away 11 times 1 plus 24. So 1 take away 11 gives negative 10, and negative 10 plus 24 is going to give us a positive 14. And that's now going to start to go off the page. And if we look at the next one, we're going to have 0 squared take away 11 times 0 plus 24. That's going to give us 24. We can't plot these coordinates. So what I'm going to do now, I'm seeing that substituting in these numbers that are getting smaller and smaller, it's actually going to give us larger and larger numbers afterwards. So I'm not going to check these. I'm going to rub them out. They are not going to be helpful. Or I can see that I'm writing down the substitutions in advance, save a little bit of time for you. If you do this on the exam, just do one line at a time so you have less to rub out if this happens. So I'm going to look instead at larger positive numbers. So let's look at 3, 4, and 5 and see where that brings us. So again, I'll write this out in advance. I don't recommend that you do it, but I don't want to waste your time talking through every single substitution when you already know how it works. So 3 squared take away 11 times 3 plus 24. So 9 take away 33 is negative 24, and add on 24, we get 0. Then we have 4 squared take away 11 times 4 plus 24. So 16 take away 44 is negative 28, and add on 24 will give negative 4. Then we have 5 squared take away 11 times 5, add on 24. So 25 take away 55 gives us negative 30, add on 24 gives negative 6. Now, while I can plot most of these points, I still haven't got a repeat value to see where the curve turns. So let's look at 6. So that'd be 6 squared, take away 11 times 6 plus 24. So 36 take away 66 is negative 30, and then add on 24 is negative 6. So now I've got that repeat value, I can see where the curve is going to start to turn. So let's start to plot. 2 and 6. That's 2 to the right and 6 up. We have 1 and 14. So I might do a little bit of an estimation here. So it's 1 across, 14 up. It's going to be quite high up. So I'm just getting into my working out. Then we've got 3 and 0. So that's 3 across and 0 up. We've got 4 and negative 4. So 4 to the right and 4 down. Then we have 5 and negative 6. 5 to the right and 6 down. And we have 6 and negative 6. So 6 to the right and 6 down. And then make sure it's symmetrical. So go 1 to the right and make it even to that one. 1 to the right again. And 1 to the right again. Now we can start to draw this. So where we have the 2 negative 6s, just come down a little bit in between them. Don't make it straight. It's not going to have a flat bottom. Then come all the way up to the top. And then just try and point it in the direction of the coordinate we estimated, and the same on the other side. And then we can have a look at the accurate version and see how close I am. And now for question 5, as usual, we don't know anything about x, but y is equal to x squared plus 13x plus 40. So again, plus 4 is quite a large number, and with everything's positive here. So I'm only going to bother to look at negative values. In a quick little bit of maths in my head, if I had to say -1, that will give me a -13 and a 40, which is going to be nowhere near plottable. There's a similar thing with -2, where with the 13, it's going to be a -26 and a 40. And so you've got 14 in between those, and that's not going to fit. I've not even thought about the x squared, which will get it even further out. So in a bit of mental arithmetic, I think the best thing to do is start at -3 and go downwards for the 6 values I'm going to look at. And again, if you don't feel confident with that sort of mental arithmetic, you will get better at it, but there's nothing wrong with starting at a +2 and just seeing where you are and adjusting from that point onwards. So we'll do our substitution. We take x, different in every substitution, and we square it. We then add on 13 multiplied by x, again with x changing for every single question. And at the end, we're always going to be added on 40. And as I spoke about, we need to have some negative numbers in our calculation to cancel out that 40. So we have values in between 10 and -10 that we can actually plot. So look at the first one. We have -3 squared plus 13 times -3, which is -39. And then we add on 40. Now, there will be calculator and non-calculator questions with these. Something like question 1 with x squared plus 5x plus 6 might be an example of a non-calculator question. But something like this where we have 9 adding on -39, which is -30, and then adding on 40 to get 10. This is something where you might have a calculator to help you. So I'm going to use a calculator to speed it up. So -3 and 10, I've got a value I can plot. So it looks like I made the right decision at the start with choosing these values. So then we have -4 squared plus 13 multiplied by -4, which gives us -52. So we do 16 plus -52, which is -36, and add on the 40 to get 4. -5 squared plus 13 times -5 plus 40. So 25 plus -65 is -40, and add on 40, we get a 0. Then we have -6 squared plus 13 times -6 plus 40. So 36 plus -78 is -42, and add on 40, we get -2. And just notice how the numbers are getting closer and closer together. From 10 to 4, that's a difference of 6. From 4 to 0 is a difference of 4. And from 0 to 2 is a difference of 2. So in one of the next two substitutions, we should start to have this curve turn back on itself and start to repeat numbers. So -7 squared plus 13 times -7. So 49 plus -91 is -42, and add on the 40, we get -2. So the curve has now started to turn. So my expectation now is that when I substitute in -8, I should be getting 0 with the numbers being symmetrical. Let's just check that. So -8 squared, and I'm adding on 13 times -8, and of course adding on the 40. 64 plus -104 is -40, and add on the 40 to get 0. So the curve has turned, and we have those symmetrical numbers. So let's start to plot. We have 3 and 10, and it was a -3, so we go to the left 3 and then 10 up. Then we have -4 and 4, 4 to the left and 4 up. We have -5 and 0, so 5 to the left and 0 up. -6 and -2, 6 to the left and 2 down. -7 and -2, 7 to the left and 2 down. And finally, we have -8 and 0, 8 to the left and 0 up. And then we can fill in the rest because the numbers should be symmetrical. So -9 should go here, and -10 should go here. Join up the curve, and there's your answer. And there's the final answer. Moving on to the hard questions now, the only difference is that we now have negative graphs. So we still have our x and y coordinate. We still don't know what the x coordinates are, but we know what the y coordinate is. And for this one, for question 1, it's -x squared. So that negative is a different part. Take away 2x plus 3. So we do the same set of substitutions that we did before. Take away 2x will be take away 2 times 2, and then we add on the 3. Now, the big thing here is that when we are squaring the 2, the negative is not part of the squaring. So when we have 2 squared is 4, you pop the negative sign on the front. The negative sign is not part of the squaring. Then we take away 2 times 2, and we add on the 3. So we get negative 4, take away another 4, so negative 8, and add on 3, we get negative 5. So this is all about handling that negative x appropriately. So like before now, I'm going to substitute in for every single value. So x is 1, 0, negative 1, and negative 2. Remember with the negative sign at the start. So when it's already negative, we'll have that extra negative symbol. And then we're taking away 2 multiplied by x. And at the end, we're always going to be adding on 3. So let's work through the substitutions. So we're going to have negative 1 squared. All right, it's not negative 1 squared, it's 1 squared, which is 1, and then the answer is negative. Take away 2 times 1 plus 3. So negative 1, take away 2 is negative 3, and add on 3, we get 0. Then we have 0 squared is 0, and the negative at the start. Taking away 2 times 0, and we add on 3. So negative 0, take away 0. We can't have negative 0, but any calculator with 0, we give you a 0, and then we add on 3 at the end to get 3. Then we have negative 1 squared is 1, and then put the negative symbol at the start. Take away 2 times negative 1, negative 2, and add on the 3. So we get a little bit complicated here. We have negative 1, and it's taking away negative 2. So double negative gives a positive. Negative 1 plus 2 is a positive 1, plus 3 is 4. Then we have negative 2 squared is 4. So that'll be negative 4. Take away 2 times negative 2 is negative 4. And add on the 3. So negative 4, take away a double negative, that's going to be an add. Negative 4 plus 4 is 0, plus 3 is 3. And now we can see we have those repeating numbers with a 3 as 2 different answers. So that's the point where the curve is turning. So now we can start to plot the coordinates. So we have 2 and negative 5. So 2 to the right and 5 down. We have 1 and 0. So 1 to the right and 0 up or down. We have 0 and 3. So 0 on the x-axis and then 3 up. We have negative 1 and 4. So 1 to the left and 4 up. And then we have negative 2 and 3. So that's 2 to the left and 3 up. And then because this is going to be symmetrical, we can start repeating these numbers. So as I go 1 to the left each time, the blue dots are on the same level as previous measurements I've taken. Now, I'm not going all the way to the bottom of the graph, so I'm going to find out one more, and we'll look at positive 3. So positive 3, that'll be negative 3 squared. Take away 2 times 3 plus 3. So 3 squared is 9, so it'll be negative 9. Take away 2 times 3 is 6, and plus 3. So negative 9, take away 6 is negative 15, and add on 3, that's negative 12. So we can't plot that, but we can get pretty close to kind of estimate where the graph's going to go. 3, negative 12, going to be roughly where I'm just putting the pink dot there, and at this other side as well. So now I can start to draw the curve. I'm going to draw the part that I do know first here. Then when I come down, I'm just going to point it in the right direction and just kind of estimate where it's going to go, like that. Now, for the last 4 questions, I'm going to try and speed this up a little bit now because I've gone through quite a few examples of this, and I don't need to show you every single substitution step. So, with question 2, we're still going to try and find the x and y coordinates. We still don't know what the x coordinate is, and this time we have negative x squared minus 3x plus 4 as the y coordinate. Now, the way to speed this up is rather than write out every single last bit on the page, we can start to use our calculator to help us now. So what I'm going to do is we're going to substitute in the same numbers. I'm going to start off with a 2. And on the calculator, we're going to type it in such a way we can use our back button to change numbers. So we're going to type in the minus. We're going to put the squaring in brackets like this. So we're going to have the number we're typing in. I'm going to represent that with a square, but you'll have a number there. So you can write in 2 for this one. Write bracket and square it. Use the square button. The take away 3. And we're going to multiply by, again, whichever number we're using, which will represent with a square. And if I type all of that into my calculator, with the square being a 2, and the coordinate I'm going to get is 2, -6. And now the way I save time now is use the arrow keys on the calculator. If your calculator has arrow keys, if it doesn't, go and buy one. I'm going to move back and find the 2's. I'm going to change the 2's into 1's. So now I have the negative symbol, a bracket. I have 1 inside the bracket, which I close, the squared symbol. Take away 3 times, then a 1, and then I add on the 4. And then I get, for substituting 1, I get 0 as my y coordinate. Then press the back button again, change all the 1's into 0's, and that gives me 0, 4. Back again, I'm going to change all the 0's into negatives. Now your calculator might start to overwrite things if you try and press the back button and put negatives in. So I'm going to have to write this out again now. So the negative symbol, open brackets, I type in -1, close the brackets, the squared sign, take away 3 times, then the negative symbol, and 1, and then add on 4. And then that will give me -1 and +6. And now I've got negative symbols in, I can press the back button, I can change the 1's to 2's, leave the negative symbols where they are, and so for -2, I'm getting 6. Then press the back button again, change the 2's to 3's, and that gets me, for -3, I get 4. So it's just a way of speeding this along a little bit. So let's start to plot these coordinates. So we have 2, -6. We have 1, 0. We have 0, 4. We have -1, 6. -2, 6. And -3, 4. Then we know this is going to be symmetrical, so if I go one more to the left and one more to the left again, they're going to be on the same level. Let's work out one more. Again, it's really easy. It's all still on my calculator screen. So I'm going to change the last -3 to a -4 and the first -3 to -4. Just remember the calculation has a -3 in already, and that's going to stay as -3. So I would get -4 and 0. Now, actually, I've already plotted -4, 0. That's one of the ones that I guessed using the symmetrical feature. And so I've got -5 again. So what I really want is -6. Change the -4 to -6's, and I get -6 and -14, which I can't plot, but I can use it to get a bit of a rough estimate of where this is going to point. So you can see I'm drawing the blue dots quite far down here for -14, but it's just an estimate. So now I'm going to join this up. Remember, when we have the 2 coordinates at 6, go a little bit above 6 in between them. It won't be a flat top to this. Then we can go down and then just use the estimate just to point it in where it roughly should be going. Then let's have a look at the computer-drawn version to see how accurate I was. And there you can see that was a fairly good estimate. So moving on to question 3 now. On your calculator, remember, a negative symbol at the front could be a little bit tricky. Make it clear to the calculator what is being squared. So writing it out like this, make sure that only the thing inside the bracket is squared and the negative on the outside isn't squared, because it'll calculate to make a positive. We're going to leave it as a negative for this. Then we're going to add on 7 multiplied by our number. If your calculator doesn't handle BIDMAS on its own, you can put extra brackets around that if you want to. Get to know your calculator. And then we're going to take away 12. So now it's simply a matter of typing that into your calculator and changing the boxes for all the numbers you want to use. For example, 2, 1, 0, -1, and so on. Just be careful. The negative numbers do have an extra character involved, so you might need to write it all out again if you need to. So when I put in 2, I get -2 out. So 2 goes in, 2 to the right, and then -2 comes out, 2 down. Then press the back button, change the 2s into 1s, and I get -6 out. So for 1, I get -6. Then looking at 0, press the back button, change the 1s into 0s, and I get -12. So again, that's a little estimate. It's going to be down here somewhere. Now, it looks like doing smaller and smaller numbers is leading me off the section of the graph that I've got. So I've done 2, 1, and 0. Let's do 3 now. So let's change the 0s to 3s. And I get 0. So if I go 3 to the right, I get 0. Press the back button, change the 3s to 4s. And I get 0 again. So now I can see the graph is symmetrical. Just in case, we can change the 4s to 5s and see what we get. And I am getting -2. So now I can plot the graph, and it should be something that looks a little bit like that. Let's have a look at the accurate version, and there you go, not too bad. Moving on to question 4. Again, we'll be changing the values of x, and we're typing into our calculator. We've got the x squared. Make it clear it's only the x that's been squared, with a negative on the outside. We're adding on 5 times x, and then we're taking away 14. Again, you don't need the brackets or in the 5 times x if your calculator has BIDMAS inbuilt. So now I'm going to type that in, and I'm going to choose a number for x, and again, I'll start with 2 and see what that gets for me. Especially with changing calculator values, it's very easy to go back and change the numbers and do a different set of calculations. So if x is 2, I'm getting 2 out. So plot the coordinate, press the back button and change it. Let's try 3. And if I try 3, I'm getting 2 again. So it looks like I've stumbled upon the top of my curve. Let's try 4, and I get 0. So now let's try 5. Again, be careful, the question has a 4 in it, so you have to have the -4 at the end no matter what. So only change the 2 4s that represent the x's. And if I put 5 in, I get -4 out. Let's put 6 in now. So now I'm changing the 5s for 6s. And again, there is already a 5 in the calculation. So leave the 5 multiplied by as a 5, and that gives me -10. So now I can guess the rest, it's going to be symmetrical. So as I go on to the left, they're going to be on the levels of the other questions and answers. So let's draw the curve, and then let's check the computer drawn answer. And there we are. So now moving on to the final question. Again, we will have variable values of x. And in our calculator, we're going to type the negative symbol, put the x in brackets so your calculator doesn't get confused. Let's start off with x being 2, so bracket 2, close bracket squared. And then we're going to add on 13 multiplied by x. So again, type in a 2 for x for our first question. And then at the end, we're going to be taking away 40. And now we can do a bit of trial and error. So when I put 2 in, I'm getting -18 out, and I can't plot that. So let's change the 2s to 3s and see what that does. And for 3, I'm getting -10, and I can actually plot that. So 3 across and 10 down. Now, if I change everything to 3, and the answer was an even larger negative number, then what I would need to do is try 1 and 0 instead. But it's pretty clear to me at the moment now that I need to be looking at larger numbers here. Let's change the 3s to 4s, and I get -4. So 4 to the right, 4 down. Then change the 4s to 5s. And for 5, I get 0. Change the 5s to 6s on the calculator display. Again, just using the arrow keys. And I get 2. Change 6 to 7. And I get 2 again. So now we've got the peak of the curve. And we can fill in the rest. So then, again, don't join the straight line. It's got to be a curve going through all the points. And now let's look at the final accurate answer. And there we are. The last thing to note with this is that you can use this method for all the other questions as well, but particularly the medium questions. If it is a positive value of x, though, make sure you don't put the negative at the start. We only have the negative at the very start of this calculation because that's in the equation of the line.
Ouch! This is why in some videos I have unexplained scratches.